Welcome to the deep dive. We're diving into a paper that has everyone in the AI world talking.
Oh, yeah.
You know how you're super into model-based reinforcement learning?
Mm,
Well, this paper is like next level stuff in that area.
cool.
It's called Improving Transformer World Models for Data Efficient RL.
Okay.
And it was published just a few days ago, February 1st, 2025, by Didu and a bunch of other researchers.
Saw that one.
So you're probably thinking, okay, another AI paper, so what? But this one is special.
How so?
Well, they came up with this new MBRL algorithm that's so good it actually beats human performance.
Well, beating humans is a big deal in AI. That means we're making some serious progress.
Totally.
Uh,
And it's not just any game they're beating humans at. It's CraftX Classic.
oh, wow. That's a tough
I
one.
know, right? It requires strategy, quick thinking, and you have to be able to adapt to all kinds of crazy situations.
Yeah, CraftX Classic is a great benchmark for testing out new AI algorithms.
So how do they do it? The secret sauce is something called Transformer World Models, or TWMs.
TWMs, huh?
Yeah, basically they let the AI build a simulation of the world inside its little AI brain.
Like how we imagine things based on what we've experienced.
Exactly. Like if you touch a hot stove,
Ouch.
you know you're going to get burned because you've learned that lesson before.
Right, that's our internal world model keeping us safe.
And that's kind of what TWMs do for AI. They help them anticipate and plan for what might happen.
Cool concept.
But the big question is, how did they make these TWMs so good that they could actually beat humans?
Well, that's where it gets really interesting. The researchers used a few really smart techniques.
Okay, I'm all ears.
They basically had a 3-step plan, and each step made the system even better.
Okay, I like where this is going. What were the steps?
First up, Dyno with warm-up.
Dyno with warm-up.
Yeah, imagine you're training the AI, right? You let it play CraftX Classic for real,
Yeah, okay.
but you also feed it these imagined experiences created by the TWM.
So it's learning from both real and fake scenarios.
Exactly. It's like a super intense training program where the AI gets to learn from actual gameplay and also from what the TWM thinks might happen.
I see. So it's not just reacting to what's happening, it's also thinking ahead.
Right. And that helps it make better decisions in the long run.
That makes sense.
Then the second step is all about how the AI processes what it sees in the game. They use this technique called patch nearest neighbor tokenizer.
Okay, that's a mouthful.
I know, right? But it's actually pretty simple. Think of it like this. The AI is looking for specific things in the game, like maybe a certain type of resource or an enemy.
Yeah.
Instead of trying to analyze the whole screen at once, it breaks it down into smaller chunks and looks for those key features in each chunk.
So it's like looking for clues instead of trying to solve the whole mystery at once.
Exactly. It's a much faster and more efficient way to process all that visual information.
Clever.
And the third step, this is called block teacher forcing, and it's all about making the TWM better at predicting what's going to happen next.
Okay, predictions are important.
Big time. This technique basically helps the AI look at all the visual elements on the screen at the same time when it's making its predictions.
So it's not just focusing on one thing at a time, it's taking everything into account.
Exactly. And that leads to more accurate and much faster predictions.
So Dyna with warm-up, patch nearest neighbor tokenizer, and block teacher forcing. That's the trifecta.
You got it. And together, those 3 techniques created this crazy efficient system.
But you know, it's interesting. They found that just making the AI bigger didn't automatically make it better.
Really? I would have thought bigger is always better with AI.
Nope, not this time.
Hmm.
They actually had to combine a larger model with a memory component.
A memory component.
Yeah, a special type of neural network called an RNN. It's like the AI's memory bank.
RNNs, I haven't heard that term in a while. Remind me how those work again.
Sure. Basically, RNNs help the AI remember important stuff from past experiences, just like our own memories help us learn and make decisions. Oh, right, RNNs. So it's not just about how much the AI can learn, but also how well it can remember and use what it's learned.
That's it. And that turned out to be super important for getting those amazing results.
So in the end, it's not just about brute force, it's about being smart and efficient.
Exactly. It's about finding that sweet spot between learning capacity and actually putting that knowledge to good use.
And speaking of putting knowledge to good use, let's take a quick break and then come back to talk about the real-world implications of all this.
It's really cool to see that for AI to do really well in complex tasks,
Yeah.
it needs to be able to remember and use what it's learned, not just learn new things.
That makes a lot of sense. It's like, it's not just memorizing stuff, it's actually understanding it.
Right,
So we've talked about how cool this algorithm is and how it's, beating humans and all that.
right.
But What does it all mean for, like, normal people who aren't AI experts? What can we actually do with this?
Well, imagine AI that can, like, control robots in factories or help out with stuff like disaster relief.
Okay, I can see that.
In those situations, being able to learn quickly from just a little bit of data is super important.
Yeah, because you don't want the AI making mistakes when lives are on the line.
Exactly. And think about things like scientific research.
Oh, yeah?
AI could maybe help design new materials or figure out complex systems way faster than we can now.
So it's like giving scientists a super boost.
Totally. It could change how we solve problems in all kinds of fields.
It's crazy to think that all this came from a simple video game.
I know, right? It shows you how research can have these crazy ripple effects.
And one thing that really stood out to me in the paper was how they talked about the quality of the world model,
Yeah.
not just the size of it.
Right.
It wasn't just about making the AI bigger. They had to make it smarter, too.
It's like you can have a huge library, but if you can't find the books you need, it's not that useful.
Exactly. So they found that adding in that memory component, the RNN we talked about,
Yeah.
that was key to getting those amazing results.
Yeah. Because it allowed the AI to not just learn, but actually remember and use what it learned.
Right, like a real student. It feels like this research is pushing the limits of what AI can do.
It really is.
Like getting us closer to a future where AI isn't just a tool, it's like a partner in solving problems.
Yeah, it's exciting to think about where this could lead.
Speaking of exciting, I bet you have some mind-blowing question for our listeners.
Let me think. What if we could take what we've learned from these AI agents,
Yeah.
the ones that are mastering games like CraftX Classic,
Right.
and apply those same techniques to real-world problems?
Interesting.
Could we create AI that can, like, design new materials
How?
or maybe even predict the stock market, all with that crazy efficiency?
That's a big question.
It is.
If AI can learn and adapt so well in these, virtual worlds,
Yeah.
why couldn't we use those same ideas in the real world?
I mean, there are definitely challenges.
Oh, yeah, for sure.
Real-world problems are way more complex. There's always stuff you can't predict.
And the stakes are higher too, right?
Absolutely.
But this research feels like a big step forward.
I think so, too.
It shows that AI can learn fast, adapt to new things, and even be better than humans at certain tasks.
It really does change what we thought was possible.
It's exciting, but kind of scary too,
I get that.
But it's clear that AI is going to be a big part of our future.
No doubt about it.
Well, that's about all the time we have for our deep dive into this awesome paper.
It was a good one.
Let's do a quick recap of what we learned.
Okay, so we talked about this groundbreaking MBRL algorithm
Yeah.
that was able to play CraftX Classic better than any human.
And they did that by using some really clever techniques.
Dyno with warm-up.
Patch, nearest neighbor tokenizer.
And block teacher forcing.
It's like a whole new way of training AI.
It is. And it made the AI learn and adapt so much faster.
And what's really cool is that they didn't just make the AI bigger, they made it smarter.
Right. They added that memory component so the AI could actually use what it learned.
That was a game changer.
Literally.
This research could really change how we solve problems in all kinds of fields.
From building robots to curing diseases, who knows what we can do with this?
It's pretty mind-blowing.
It is. AI is moving so fast, it's hard to keep up.
Well, we hope you enjoyed this deep dive and maybe learned a thing or two about the incredible world of AI.
And who knows, maybe one of you listening will be the next AI superstar.
Thanks for joining us.